Welcome. Today we're going to learn how to divide complex numbers. What I mean by that is we're going to start out very simple. Complex number in general will have an I. Doesn't have to have an I. Real numbers are considered a subset of the complex numbers. But if I take I and divide it by I, hopefully you're all smart enough to realize that any number, even complex numbers, divided by itself is 1. So if I gave you 4i divided by 4i, you would say that's 1, right? So they might give you something very simple like 3i divided by 5i, and guess what? The i's cancel and we're left with 3/5, right? And now remember, by the way, all complex numbers can be written in the form of a plus bi, where a and b are real numbers, and a lot of times they'll be fractions. So I'm left with a fraction, right? Now, they might start to throw in where we don't have I both top and bottom. They might give you something as simple as 2 divided by 3i. Well, now what do we do? Because the complex number cannot be written with an I in the denominator. The I is always up top. So how do we remove an I from the denominator of a fraction? Well, just like any fraction, as long as I multiply by 1, it doesn't change the value of the fraction. It might just change the way it looks. So what I'm going to do is multiply by I over I, which is 1. But I'm actually going to multiply these two together. I get a 2i, and then over 3 times I squared. But what's I squared? Well, it's -1 times the 3. So I get a -2/3, and then the I sits kind of behind the fraction. The I sits behind the fraction, or it's times I. But you notice what happened is all that really happened is it changed sign and became 2/3, and the I moves up top. So again, very simply, if I gave you 5 divided by 7i, that's just going to be a -5/7 I. And again, to make sure you understand why that is, I would take the 5/7 I times it, top and bottom, by I. That's my 5i on top. That's a -7 on bottom. I times I is I squared. I squared's -1. -1 times 7 is -7. And then you just write it with the I sitting behind. And I usually put the negative in front of the fraction. So it just changes the sign. Now, we're going to continue on in our exploration of this division of complex numbers, because what they might do is they might divide not by just a single term like 7i, they might divide by 2 plus 3i. Now it's going to be a little bit harder because we want to be able to eliminate the I, but I cannot just multiply top and bottom by I. If I did that, I'd get an I on top, and then I would have to distribute this I in, and I'm going to get another I on bottom. It didn't help, right? By the way, why did that become -3? Because I times I is I squared. I squared is -1 times 3 is -3. But that didn't help. So that didn't work. So what we do is we actually multiply what we learned in a lesson or two ago by the conjugate of what the bottom is. So the conjugate is going to be the same two terms, but I'm going to change that sign in front of the I term. So I'm going to do a 2 minus 3i instead of a 2 plus 3i. But I'm going to do that to the bottom and the top. Because remember, this is just 1. By the way, I think they might even try to trick you sometime, and they might go, what's 4 plus 3i divided by 4 plus 3i? I'm hoping you don't take the time to multiply top and bottom by the conjugate, because what's any number divided by itself? It's the top and bottom of those fractions are exactly the same. That's just 1, right? So again, here, I'm just multiplying by 1. But here, these two, I need to FOIL together. 1 times that's just going to give me a 2 minus 3i. And I am technically foiling that in or distributing that in, but it doesn't change anything. But now here, 2 times 2 is going to be 4. So I'm going to distribute, and now 2 times negative 3i is going to be a minus 6i. 3i times 2i is going to be a positive 6i. And 3i times a negative 3i is going to be a positive 9i squared. Positive 3, negative 3, that's my, whoa, sorry, not a positive. Positive times a negative, that's going to be negative, but then the I squared, which is another negative 1, again, I want to make sure you followed. Positive 3 times negative 3 is negative 9. I times I is I squared. The I squared, though, is a negative 1, so that changes it to a positive, and that goes away. So now, if you'll notice, I have a 4 plus a 9, which is 13, and the two middle terms cancel. Negative 6i and 6i cancel each other out. Now I don't have I in the denominator, but it's still not written in the right form. Remember, we got to write it in a plus bi form, so I separate that into two fractions. I'd write it as 2 over 13. That's that first term divided by 13, minus that second term divided by 13, and I'm only going to do the 3 over the 13, and the I that's in the top I'm going to pull out behind, and now I'm in the form of a plus bi. So 1 divided by 2 plus 3i is actually 2/13 minus 3/13 I. Let's do another one. This time, though, I'm not going to do like 1 in the numerator of my complex number. I'm going to do like let's do a negative, I don't care, 5i. And let's divide that by a negative 3 plus 6i. So again, the bottom of that complex number is a two-term expression, and it has an I involved. I want to get rid of it. Do not just cancel these I's. You can't do that because of this 3. The I's do not just cancel. What I'm going to do is I'm going to, whoops, sorry, not equals. I'm going to times it by the conjugate of this. The conjugate is going to be a minus 3 minus 6i. Remember, I changed the sign in front of the I term, not the non-I term. But if I multiply the bottom of the fraction by that, I'm going to multiply the top. So I'm really multiplying by 1. If it helps, put these in parentheses so you'll remember to distribute or FOIL. So I'm going to do the negative 5i times the negative 3. That's going to become a positive 15i. Negative 5 times negative 3 is positive 15, and we have 1i, right? Negative 5 times negative 6 is going to be a positive 30, but I times I, or I squared, is going to be a negative 1. We'll get there in a minute. Over negative 3 times negative 3 will be positive 9. Negative 3 times a negative 6i will become a positive 18i. 3 times 6 is 18. Both were negative, so it's positive, and there was an I involved. Now here we have a positive 6 times a negative 3, so that's going to be negative 18, and there's an I involved. And then positive 6 times minus 6 is going to be a minus 36, but then we have an I and an I, which is an I squared. Okay, well, these two right here, these I squared becomes a negative, so that's going to become a 15i. That doesn't become, there's the 15i in front, and this becomes minus 30. Over. The two middle terms cancel. 18i minus 18i cancels. This is an I squared, so that's going to be a negative 1 times the minus 36, which is going to make it plus 36. Now, I want the I term behind, so I'm going to swap the place of those two. I'm going to put the minus 30 in front, the plus 15i behind, over 9 plus 36 is what? 45. Now, we're going to separate that into two fractions and reduce. Okay, when I separate it into two fractions, I get a negative 30 over 45 plus 15 over 45i. Well, 30 and 45 both have 15 in common, just like 15 and 45 do. So what that's going to happen is divide both top and bottom by 15. I'm going to get a negative 2 over 3 plus divide by 15. I'm going to get a 1 over 3, and then the I sits out behind. So if you don't remember what the first original part was, it was negative 5i divided by negative 3 plus 6i. That becomes that. Let's do another one. This time, and notice, sorry, I'm going to keep moving around a lot. This one only had one term on the top. The most complex ones you're going to get is going to have two terms. You might have something like negative 5 plus 5i over 3 plus I. Again, we have two complex numbers, one of them divided by the other. The i's do not cancel. Don't separate that into 5/3 and 5i over I. You can't do that. What you have to do is multiply by the conjugate of the bottom. So I'm going to multiply 3 by a 3 minus I, top and bottom. Again, if it helps, put your expressions in parentheses, and we're going to FOIL or distribute. Negative 5 times 3 will be negative 15. Negative 5 times negative I will be a positive 5i. 5i times 3 will be a positive 15i. And 5i times negative I will be a negative 5i squared. Over 3 times 3 is 9. 3 times negative I will be a negative 3i. I times 3 will be a positive 3i. And I times I, well, and it's positive and negative, so it's going to be a negative I squared. Now, when you do this, you will you should always get i's left in the top. And so these two middle terms don't cancel, and don't think they do in the top. They will cancel in the bottom. But in the top, we have this minus 15. 5i plus 15i is going to be 20i. This I squared is a negative 1, which is going to change this to a plus 5, all over 9 plus 1, because the I squared is a negative 1, and when you minus a negative 1, you're adding 1, so that's going to be 9 plus 1. The two middle terms in the bottom do cancel, which is what we wanted. Negative 15 plus 5 will be negative 10 plus 20i over 9 plus 1 is 10. Separate that now into two fractions. Now we can separate. You can only separate once you have a single number in the bottom. Never try to separate when there's two terms in the bottom, only when there's one term. But I'm going to get a negative 10 over 10 plus 20 over 10i, which reduces to a negative 1 plus 2i. So this expression here of a negative, I'm going to even rewrite it, negative 5 plus 5i divided by 3 plus I becomes a negative 1 plus 2i. Negative 1 plus 2i. Again, if you have questions, please bring them to class and I will walk through this again.